We can multiply a vector by a scalar. For example, if I have a vector in 2 dimensions, just x and y, I can write it in this form, or I can write it as xi plus yj. This just means x times a unit vector in the x direction plus y times a unit vector in the y direction. Then k, some scalar, times a vector, will be k times xy, which can be written as kxi plus kyj. This just means it's in the x direction times a unit vector. This just means it's in the y direction times a unit vector. We can also do scalar multiplication of vectors in 3 dimensions. For example, if a in 3 dimensions, this is our vector, is broken down as components x, y, z, we can write it in this form or as xi plus yj plus zk, remembering that I, j, and k are just unit vectors in the x, y, and z directions respectively. Then a scalar k times our vector a is simply k times, we substitute, we multiply out kx, ky, kz, and of course we can write this as kxi plus kyj plus kzk. We can now talk about further properties of vectors in 2 dimensions and 3 dimensions. First, we want to talk about the magnitude of a vector. The magnitude of the vector, if it's defined in terms of I, j, and k, remember that's just the unit vectors in the x, y, and z directions, then we can use the Pythagorean theorem. Remember that when we're finding the magnitude of a vector, we're looking at the length of the vector, and length is absolute value of a. If we're talking about vector a, the length would be absolute value of a, therefore the length is always going to be positive. Here's a good example of finding the magnitude of a vector in 2 dimensions. I've got vector a defined as xy, which is xi plus yj. Go over x and up y. This is a position vector because our tail is at 0, 0. A position vector has its tail at 0, 0. So we see that the magnitude of a is the absolute value of a squared is equal to x squared plus y squared, because we've got a 90-degree angle there. We're just using Pythagorean theorem. So a, the absolute value of a, or the magnitude of a, is x squared plus y squared, all in the square root. That's how we find the magnitude of a in 2 dimensions. We've already talked about how to find the magnitude of a vector in 2D, and we said we had to use the Pythagorean theorem. It's the same in 3 dimensions. Here I've got a vector a in 3 dimensions. Remember, this is your y direction. J is just a unit vector in that direction. This is your x direction. It's coming out of the board. I is just a unit vector in that direction. And your z direction goes up and down, and k is a unit vector in that direction. If a is from our origin O and coming out of the board at us like this, well then I've got 3 components. I've got the y component here, the x component here, and the z component here. Well, the magnitude of a, if vector a is xyz, which is xi plus yj plus zk, then the magnitude of a is simply the square root of the x component squared plus the y component squared plus the z component squared. Why does that work? Let's take a look at OP. OP squared is equal to, well, look at this triangle. That's QP and OQ. OQ and PQ, or OQ and PQ. I'm just looking at this triangle here. Well, I can keep PQ squared, which is really my z. And OQ squared, this line here, is made up of the components x and y. So I can substitute x and y for OQ. And it turns out, yes, this is sort of the proof that a squared is the absolute value, or the magnitude of a, is equal to x squared plus y squared plus z squared. I could square root both sides and get this. The main point of all of this is that if you want to find the magnitude of a vector in 3D, again, you're going to have to use a Pythagorean theorem. And this is something you'd want to remember. We can now talk about the concept of the unit vector. A unit vector is a vector of unit length, meaning length of 1, in the same direction as our original vector. Our sign for unit vector is a with a little hat over it. It's also known as a hat. It could be vector b, then it would be b hat. Vector c would be c hat. For example, if vector a here has a length or a magnitude of 4, how do you find a hat? Well, you must divide this by 4 to get a unit vector. Let's do an example of finding a unit vector. If I have a vector r defined as 5i minus 2j, here's my vector r. Its components are, in the x direction, 5i, and in the y direction, negative 2j. Find the unit vector r hat. Well, here's our formula we need to know. R hat is equal to the vector r divided by its magnitude. Well, the vector r, we can't do anything with that. That's 5i minus 2j. And we know we have to use the Pythagorean theorem to find the magnitude of r, which would be 5 squared plus negative 2 squared square root, which turns out to be the square root of 29. So in this case, the unit vector r hat would be the vector r, copied as it is, divided by the magnitude of vector r. And we're done. This is the unit vector.